you run the risk of ending up with potentially confusing. If you're doing meter seconds, that is not the same as a millisecond, so the dot is crucial in cases like that. All right, it is just add them together. It's a one-dimensional problem, so we can get away with just adding them straight up like that. If it's a two-dimensional problem, then you're adding vectors in 2 dimensions, so I add j hash probably the simplest way. If they collide and stick together, what's the total final momentum? Ooh.
It should be 2 as well, right? Because
Yeah.
conservation.
Absolutely. Suppose they hit each other and bounce off each other. What's the total final momentum?
Still going to be 2.
Yeah. I have asked this on a number of tests where I have them set it up, they collide, I say, what's the momentum of this, what's the momentum of that, what's the total momentum before the collision, they collide in such type of collision, what's the final momentum? Shocking the number of people who miss it. Total momentum initial equals total momentum final. There's going to be a caveat in there, but that's good enough now. So if they stick together, so let's go ahead and do that. I know that P final is equal to 2 Newton seconds. That's got to be equal to mass times velocity. What is my mass if they stick together? Absolutely. Where else would the mass go? If the mass went somewhere else, we'd suddenly deal with a much more complicated problem. Then they hit and explode. So 8 kilograms times the final velocity. And so my final velocity, 0.25 meters per second. It is positive, which means that they will collide and move to the right. My math problem here, I have 2 is equal to 8v. Solve for v. My momentum is mass times velocity. That's the mass times velocity. Solving for this, I divide both sides by 8 kilograms. 2 divided by 8, 0.25. Unless, of course, usual, the math people have lied to us. Questions? All right, so let's talk about the fact that they stuck together. Because you basically have 2 options there. They hit and stick, or hit and don't stick. We are ignoring shattering, which I guess is also a possibility, but if they stick together, well, basically, if they lose energy, that is considered an inelastic collision. So there's a whole range of possibilities if it's an inelastic collision, and the most extreme is they stick together. That's when you get maximum kinetic energy loss. And so that's what's called perfectly inelastic. So perfectly inelastic collision, we have maximum energy loss, maximum kinetic energy loss. If there's just kinetic energy loss, it's an inelastic collision. If there is no loss of kinetic energy, that is a perfectly elastic collision. So you might look at that and be thinking, well, why is it perfectly elastic? Isn't it just elastic? Well, yes and no. The naming convention is not set in stone. There'll be some textbooks, some sites, that actually will call the first one inelastic, call this one elastic, and this one perfectly elastic. There are other systems that will call this one elastic, inelastic, perfectly inelastic. So if you just say, if someone just says it's an inelastic collision, it could mean one of two things. So, I do not remember what any textbook does. Unfortunately, I have too many different textbooks and I don't keep a track. I can't keep it straight. So I came up with, hopefully to clarify it. Actually, I'm gonna make one change here, not inelastic here. Imperfect. I got my two extremes, which are perfect. One's perfectly inelastic, they stick together. One is perfectly elastic, kinetic energy is conserved. And let's actually write that down there. Delta K equals 0. And then I've got that middle one, which is imperfect. And so that's the language that I'll be using on quizzes and tests and homeworks, etc. I will shorten the first one, perfectly inelastic collision, to PIC sometimes. So, and this one, PEC, just as a shorthand notation. Yeah, Riley.
Can you explain a scenario where it's perfectly elastic?
A real life scenario?
Or just any.
These two objects are heading towards each other. They will collide in a perfectly elastic collision. What are their velocities afterwards? That, in terms of real life situation, if you're dealing with particle physics, there's really no friction involved there. You have two particles that are coming towards each other. They can glance off each other. Momentum is conserved, and energy is conserved there.
Okay.
All right, let's actually solve the perfectly elastic version of this. Good news, lots of math. Potentially better news, there's some shortcuts. Worse news, there's 3 different ways of solving it. I'll go through all 3 of them. Some students start mixing and matching as they start doing the different techniques. That's not so good. Pick a technique, learn it on the test. On the last test, there will be a perfectly elastic and a perfectly inelastic collision. Just telling you right up front. There's an equation in the book which talks about, for the perfectly elastic collision, here are the final velocities. I gave you one complex formula. I'm not going to give that to you. All right, so we have a 3 kilogram mass heading to the right at 4 meters per second. Let's go ahead and keep the same convention we just had. To the right is positive. We have a 5 kilogram mass going to the left at 2 meters per second. I know that they are going to collide in a perfectly elastic collision because I just said that they were. I know my total initial momentum is the momentum of A plus the initial momentum of B, which is 12. I have it defined over there, 12 Descartes plus negative 10 Descartes, or 2 Descartes, which must be my final momentum. It would be really helpful for you, and for me too, if whenever I give you a problem where there is a collision, you immediately think conservation of momentum. I don't know what the velocities are afterwards. I have 2 unknowns. I'm gonna have V, I guess 3 final, and V 5 final. Changing my convention midstream there, so that's just 3, that's a 5. I'm gonna first write it out using the subscripts. I'm then gonna do a substitution because the more subscripts I write, the more chances I am to make a mistake. So I have 2 unknowns, so how many equations do I need?
2.
At least, yeah, 2 independent equations. So my first one is I have 2 equals 3 V 3 final plus 5 V 5 final. That is my first equation right there. My second equation comes from the idea that kinetic energy is conserved. So my initial kinetic energy equals my final kinetic energy. I'm about to ask the question that all of you know the answer to. Here we go. What's the formula for kinetic energy?
1/2 mv squared.
Seems like either you got perfectly in sync or it died out after the first word. Thanks for going for it. That was rather sad though. Let's do it again. What's the formula for kinetic energy?
1/2 mv squared.
Sort of the word jazz approach. All right, anyway. So I have 1/2 times 3 times 4 squared plus 1/2 times 5 times 2 squared equals 1/2 times 3 times V3 final squared plus 1/2 times 5 times V5 final squared. I now have 2 equations, 2 unknowns. Let's solve it. Questions before we actually have to solve it?
Why did we use the kinetic formula again?
Because it's a perfectly elastic collision. In a perfectly elastic collision, kinetic energy is not lost, which means the initial kinetic energy equals the final kinetic energy.
Okay.
That's why. Notice that we do have the advantage. The advantage of energy, conservation of energy, is we don't have to worry about vectors. Direction does not matter. The disadvantage is we lose some information when we ignore the direction. Momentum, the advantage momentum has, conservation momentum, is that it's a vector quantity, so we don't lose direction in our answer. The disadvantage is we're dealing with vectors and it's more complicated. But combined, they produce the powerful fighting force. Now at this point, I don't want to have to keep writing subscripts, so I'm going to make a letter substitution here. I'm going to let this be, not with that. We're not using these letters at all. Capital M, capital. Something else. How about M and Q? We're going to do M and N, but I wanted 2 letters that look very different. Now typically I choose C and D, but I'm using D for that. So my first equation is 2 is equal to 3m plus 5q. My second equation, I've got 1/2 times 3 times 4 squared, which is 24, plus 1/2 times 5 times 4, which is 10, is equal to 1.5 big M squared plus 2.5 Q squared. Assuming I've not made a careless error. equals 1.5 m squared plus 2.5 q squared. And so I've got these two equations, two unknowns. How do you solve it?
You can solve for one of the variables in the first problem and then insert it in the second one.
All right, which one do you want to solve for?
M.
So we have 3m is equal to 2 minus 5q. M is equal to 2/3 minus 5/3 q. Plug it into the other equation. We have 34 is equal to 1.5 times 2/3 minus 5/3 q. Quantity squared plus 2.5 q squared. You might notice we're heading towards a quadratic equation. Actually, I guess officially it is a quadratic equation. We're heading towards a standard form quadratic formula. So I have 34 is equal to 1.5 times that squared. 4/9 minus 20/9 q plus 25/9 q squared plus 2.5 q squared. Got my close parentheses. Since I got fractions there, that's 3/2. Distributing, I get 34 is equal to 2/3 minus 10/3 q plus 12.5/3 q squared plus 5/2 q squared. Hoping I haven't made a Garrel's error yet. But the advantage of this, even though this is sort of a pain and the other ways are simpler mathematically, there is an advantage to this, which we'll hopefully see. If we don't see it, at this point, I will recognize immediately whether we have a wrong answer or not. And shortly after, you will recognize whether it's a wrong answer or not. Put it in standard form. I'm gonna put it in something q squared plus something q plus something equals 0. So let's add these together. So 46 q squared minus 10/3 q equals not equals minus 33 1/3, 100/3 equals 0. Because that would be 33 1/3 negative. Okay. I'll be shocked if I haven't made a Garrel's error. I assume people are checking as you go. Now what?
We look for the roots.
Pardon?
We look for the roots. So like we have this quadratic formula, and then if there could be like, I'm guessing one negative, one positive, but there's double positives, I guess it's gonna be the highest number. Would that make sense?
Take the highest number, good. You're gonna get two numbers,
Yeah. And-
granted.
Yeah.
They're not the answer is not necessarily a positive answer.
Mm-hmm.
This is a velocity, so if the velocity is negative, it means it's going that way. Velocity is positive, it's going that way.
So the two roots would be both of the answers at the same time.
Wait, say that again?
So the two roots that we get from this quadratic function are the two answers for the.
No,
Okay.
only one of them will be valid.
Okay.
One of them is the way, well, we'll get there. Let's get our two answers and figure it out. Actually, before we use quadratic, I am gonna do something else. I'm gonna multiply everything by 6/10. just to simplify the numbers here. So this would end up being 4q squared minus 2q minus 20 equals 0. We can simplify it one more step. 2q squared minus q minus 10 equals 0. That's 20, there's 5, okay, that. That's 10 more than that. All right, I'm feeling like that's right. Now, occasionally I set it up so that you end up with integers as the final answer. And sometimes I do that and then say, hey, the answers will be integers, that way you know if you got it right or not. And again, it's a double-edged sword of if you get it wrong, what do you do next? All right, so q equals 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 10 divided by 4. What are our two answers? Actually, this might come out. That's it. So 9. So we're gonna get 2.5 or negative 2.
Mm-hmm.
Which is the correct answer?
It's the negative number, because since that we established that the positive direction is that way, so which means that the velocity has to be a negative, since it's going the opposite direction, the positive direction. So it has to be negative 2, right? Because, or are we looking for speed or velocity?
Velocity.
So negative 2.
Negative 2 is not the correct answer.